Lately, we've been hearing a lot about quality in Ameritech. It's not that we haven't been concerned about it before, we always have. We prided ourselves on the quality of service we've traditionally given our customers, but time brings change. And right now we're involved in some of the most rapid changes we have ever experienced. For the first time in our history, we can actually lose customers in very big ways. We have to ask ourselves, how can we keep our customers? How can we foster an environment in which our customers remain loyal to us amid all the ads, projected prices, and promises of our competitors? We can answer the questions by asking ourselves, what do we want from a company, any company? What do we expect? What do we demand? The answers are price, product quality, and service. We can't kid ourselves into thinking that we're not involved in all of these areas. We may think we don't set pricing, but we are part of that price. Every time a job has to be done twice, we raise the cost of doing business. Every minute we spend on a job adds to the cost. As technicians, you need to recognize your own importance and what you mean to the company. You have to recognize that to our customers, you are the company. To them, your quality standards are Ameritech's quality standards. The pride you have in your work is Ameritech's pride. To our customers, you represent Ameritech. You represent your coworkers, you represent yourself. If you take pride in the quality of work you do, you're taking pride in yourself, and you're helping to assure a bright future for Ameritech as well as yourself. We have to face the fact that Ameritech's survival depends on each one of us doing the highest quality job we can. We may feel that we're a mere cog in the machine, but we're an important cog. So quality means a lot to us, doing things right the first time, repairing a job quickly, making sure the customer is satisfied, and doing these things day after day after day is what quality is all about. The Quality Series videotapes are designed to help sharpen the skills that you already have and to give you that all-important competitive edge. In today's tape, we're going to talk about bonding and grounding and its importance in doing a quality job. Enjoy the tape.
The environment of aerial plant is not always this friendly. Sometimes it can get pretty hostile. Wind, rain, snow, bitter cold, and the exposure to high voltage contacts from down power lines and lightning make it imperative that we properly bond and ground aerial telephone plant. Hi, I'm Mick Scriva. Welcome to the Quality Series. Today you'll see how to bond and ground telephone support strand and down guys to an effective electrical ground. We'll also see how to bond and ground an aerial splice. Before we get into that, let's define exactly what bonding and grounding is.
Bonding is electrically connecting two or more pieces of telephone hardware to ensure that hardware shares a common electrical potential. Grounding allows a high voltage charge to pass directly to an effective electrical ground without damaging the plant or the technician working in the area.
The possibility of injury to employees and the general public is far greater in aerial plant because of its exposure to the elements and foreign power sources. This is why we establish strand continuity by bonding strands and down guys and then by connecting those strand bonds to the multi-grounded neutral.
Telephone support strands are made of steel and are highly conductive. If not bonded together properly and one of them becomes energized, the electrical charge could arc across the distance seeking a path to ground. And if a technician is working there when that happens, it could result in a tragedy.
Okay, Dave, how do we establish strand continuity on this new construction here?
Well, Mick, we have a situation here where there are two strands attached to this pole by separate hardware. We have to make sure with separate strands like these, they're bonded together at the first pole where they start and at the last pole where the separate strands end.
Failure to properly bond aerial facilities can result in losses to telecommunications plant and equipment from lightning damage or foreign power and can result in serious injury. The examples you now see identify the correct bonding procedures for telco facilities when occupying the same telecommunications space as other authorized licensees, for example, cable television companies. Some guidelines for bonding strand are: Where a bond is placed between the power company multi-grounded neutral, or MGN, and a suspension strand, all other suspension strands, permanent or temporary, on the same pole must be electrically connected to the bond. Strands must be bonded at the first and last poles at each crossover and at each branch. Strands must be bonded at intervals not to exceed 1,500 feet along the lead or at every location where a power company MGN vertical ground wire exists. The main reason for bonding all strands in the communication zone at every MGN is to reduce shock hazard to any technician climbing the pole. The second reason is to reduce damage and any service interruptions that might be caused by lightning or power surges. When aerial and buried plant is installed along the same path as power, the strands and conductors may act as capacitors, arcing and destroying the plant that is not bonded and grounded.
So in order to maintain a common electrical potential in both strands, you have to connect one of these. Number 6 ground wire at each strand. Dave, you want to show us how this is done?
Well, first you have to strip about 2 inches of sheath covering off of both ends of the ground wire.
All right.
And after we strip the ground wire, we'd secure it to the pole with a couple staples.
All right, hold that for you.
Yeah, thank you.
Okay, Dave, I see you're bending the ends there. Does that mean you're just going to hook them around the strands? Is that it?
No, you double the wire over so more of it makes contact with the strand when you tighten down the bolt of this clamp.
Oh, okay, that makes sense. And you're using the B-strand ground clamp, right?
That's right, Mick. To secure it into place, put the ground wire, the strand together, tighten the clamp down on both of them.
That's good. Oh, it's easy enough. Use a wrench. Beautiful. Okay, what about this bottom cable here, Dave? This looks like it's self-supporting. Do you have to bond it the same way?
Sure, you still use the same ground wire, but with self-supporting cable, you have to use a C or D strand ground clamp.
Okay, and what kind you got there?
This is a C clamp. When you tighten down the clamp, the teeth bite through the jacket to provide contact and strand continuity.
Strand continuity is important. If we don't maintain it by bonding parallel strands or at a corner pole like this by bridging over to a separate strand, we increase the risk of serious injury or service interruptions. Now, we've already seen how to bond telephone support strand for a common electrical potential. But let's examine the process of connecting those bonds to an effective electrical ground. Okay, I guess first we better define what is an effective electrical ground.
The cables and materials Ameritech employees work with are highly conductive and can carry hazardous voltages of electricity if not properly grounded. An effective electrical ground is a low-resistance ground. It prevents the buildup of hazardous voltages and telephone plant in the event of contact with lightning or a foreign electrical source. An effective electrical ground can be a multi-grounded neutral provided by the power company, or an extensive underground bonded buried system like that found in a manhole or a CEV.
This molding covers a vertical lead from a multi-grounded neutral provided by the power company. Now this multi-grounded neutral vertical, or an MGNV, runs the length of the pole and extends a safe distance into the ground. Let's check with Dave on how to connect to this MGNV. Okay, Dave, you want to show us how to bond to the MGNV?
Sure, Mick. I have my rubber insulated gloves on.
Beautiful. What's the next step?
First, we remove about 6 inches of the plastic molding that covers the multi-ground neutral vertical.
Okay, let's do it. It's not real easy to cut through.
A little tough.
There you go. Bingo.
Okay,
Now what?
now that we've got the plastic molding removed, we remove about 1 inch of insulation covering the wire.
Looks good. Now what?
Then we're ready to test it with our 188A test set.
You got that right here. There you go. This makes sense because you want to see if the wire lead you bond to is energized.
Okay, we have a green light.
Green light. Beautiful. So Dave got a green light when he tested it, which means all systems are go. Had he gotten a red light, he would have ceased operation immediately and contacted his supervisor. His supervisor would have contacted the power company. Well, we've attached another number 6 ground wire to the strand that's in our continuity circuit and secured it to the pole here. Now Dave's going to bond it to the MGNV using a clamp. What kind of clamp is that, Dave?
This is an H clamp used on multi-ground neutrals with a copper vertical. If the vertical were aluminum, you'd have to use a B connector.
Gotcha.
Whenever a bond is made between the power company's multi-grounded neutral and a strand, all the strands on the same pole have to be electrically connected to that bond.
In this example, we first established continuity with these strands here, here, and here. Then we connected one of them to the MGNV, giving us an effective electrical ground. In addition to bonding telephone support strand for continuity and grounding it to an effective electrical ground, another area of concern with aerial plant are down guys. Now in a corner pole like this, there's generally one down guy for every strand on the pole for tension support.
By placing a bond between the strand and the down guy, a high voltage electrical surge will partially dissipate into the down guy as it moves along the cable path. And conversely, if the down guy was impacted by a power surge, a bond from it to the support strand would provide an avenue to the multi-grounded neutral. Without a bond between the strand and the down guy, a high impact charge can energize the down guy and arc into the air, posing a hazard for anyone in its path.
When you think of the consequences of not bonding support strand and down guys, it's easy to understand why it's so important. Okay, Dave, old buddy, you want to show us how to bond and ground down some down guys here?
Well, there are a couple of ways. The easiest is when the strand and down guy are electrically connected by the through bolt, such as these two strands and these two down guys.
And you're talking about this through bolt here, this through bolt here.
Right.
Okay, so if you've got a strand and a down guy secured to the pole by a common piece of hardware, they're considered to be electrically connected, metal surface to metal surface. All right, Dave, that takes care of these two guys, but what about this down guy over here and this strand?
This down guy over here provides tension support for this self-supporting cable over on this side of the pole.
Yeah, okay, but they're not connected by a piece of common hardware like these two are.
Right. We have to connect the number 6 ground wire from this down guy over to this strand of the self-supporting cable.
All right, well, let's do it. Once again, Dave has taken number 6 ground wire and secured one end of it to the down guy with the type B clamp, and took the opposite end of the ground wire and secured it to the self-supporting strand with the type C clamp, which will bite through the strand jacket and provide continuity.
That's right.
Now all down guys have to be bonded to a ground. You can do that by either bonding directly to the multi-grounded neutral, or, like we just did, bond to a strand, which is part of the circuit of continuity that eventually leads back to the multi-grounded neutral. Well, Dave, we want to thank you for all your help and your expertise today and showing us how to ground and bond telephone support strand and down guys. Appreciate it.
My pleasure, Mick. You're welcome.
Yeah.
All polyethylene cable sheets must be bonded to the strand at every splice location and at a minimum of every 1,000 feet. Now, lead lash cable doesn't require any sheath bonds because it's automatically bonded to the strand by the lashing wire that supports it. Lead ring-supported exchange cables do require a sheath to strand bond at the first and last pole of its run and at every 10th pole in between. However, if there are no power lines on the same poles as ring-supported cable, no sheath to strand bonds are required.
Well, we've covered a lot today, from how to bond support strands and down guys to safely connecting them both to a multi-grounded neutral. Now, one thing you should remember about bonding and grounding aerial plant is that it not only helps in noise reduction for the customer, but it also helps to protect you and the general public from possible high voltage electrical injury. Well, if you have any questions about what we covered today, review this tape, read your BSPs, and check with your supervisor. Good luck, and we'll see you next time on the Quality Series.
Documentation relating to any part of your job can be found in Ameritech's quality book, The Final Touch. Make sure each of you has a copy of this book. It can probably answer most of the questions you have about the job. And remember, quality counts. Now more than ever, doing a quality job means keeping a customer.